These are the learning outcomes of today's session. By the completion of this talk, you will get insights on the basic concepts of machine learning. You will be familiar with various classification algorithms. You will also be able to identify a suitable machine learning technique for a given classification problem, because we'll see some classification algorithms and we will also see that for which kind of problems they are suitable. You will also get insights on TensorFlow, which is a very popular tool to implement machine learning models. Both, it is useful to implement both supervised as well as unsupervised models. So we will see TensorFlow also, not in depth, but I'll introduce this TensorFlow tool, which is used to implement machine learning as well as deep learning models. This is the flow of today's discussion. Machine learning basics. I understand that you might have already received a lot of introductory information about machine learning, but still I need to throw some light on machine learning with reference to today's topic. So I shall start discussion with machine learning, wherein I will discuss need of machine learning, evolution of machine learning, major applications of machine learning in day-to-day life, terminology related to machine learning and machine learning process. Now, once I discuss the fundamentals of machine learning, I shall discuss the types of types of machine learning, which are supervised and unsupervised learning. Then we will explore the two major categories of supervised learning, classification and regression. Regression I will cover only if time remains, because as I have told you, I observed that you have received a very good in-depth knowledge on regression, theoretically as well as practically. So I may skip also. And types of regression, as you have learned, as I have told you, and I hope you have learned linear regression, polynomial regression, decision tree regression, then random forest regression, logical regression, logistic regression. So you might have studied all this. So my job will be easy today here. I'll not go much into a detailed discussion of regression, but we'll see the classification. Okay, fine. And then after discussing this classification problem and algorithms that are used to solve the classification problems, we will discuss TensorFlow, which, as I have told you, it is a tool to implement machine learning models and deep learning models. I did this because I was introduced in last session. So let us start with machine learning basics. This is just to recall the data science process discussed in the last session. And as we discussed in the last session, machine learning is used in the fourth step of this process. Right here, machine learning is used to model the data after cleaning the data and performing exploratory analysis. This is cleaning, this is exploratory data analysis, and here we use the machine learning to construct the model, right? So this is just to for review. Okay, this was also discussed in last session, but not in depth. I provided overview that why we need machine learning. So in general, why we need machine learning, or we can also say that why we need machine learning for data science, right? So here are the reasons that why we need machine learning today. The need for machine learning engineers are high in demand, and it is due to evolving technology and generation of huge amount of data. So these are the four reasons for why machine learning is so important. And the first reason is increase in data generation, right? So needless to say that there is a massive amount of increase in data generation today. Since the last decade, we have been generating an immeasurable amount of data since last 1 decade, right? And with availability of this so much data, it is possible to build predictive models that can study and analyze complex data to find useful insights and to deliver more accurate results, right? And due to this excessive production of data, we need a method that can be used to structure, to analyze, and to draw useful insights from this data. So this is where machine learning comes in picture, and it is required, and it uses data to solve problems and find solutions to most complex problems in industry. I gave you a few examples in last session, but today I'll give you more examples. That why it is required. The top tier companies like Flipkart, Netflix, Amazon, Facebook, Pinterest, they all on the sites we are generating a lot of data daily, right? Rather, we can say that every minute we are generating a lot of data, and using this data, these companies they build machine learning models using this tons of data. They use this machine learning models to identify profitable opportunities and to avoid unwanted risks, right? So you will find numerous examples on Google about the what machine learning is and why these companies, top tier companies like Amazon, Flipkart, they use machine learning. However, let me give you a few examples here. Netflix, it uses machine learning. Because constantly it uses machine learning to constantly improve the recommendations and personalized problems. So it is also done based on data we are generating on Netflix, right? It analyzes, it observes that what shows you watched in last 1 month or last 1 week, and based on that recommendations are provided. So there we are, Netflix is using machine learning. Uber example I discussed in last session, so I can skip it, right? Okay, most of you might be using this Spotify app to listen music, right? After Savan, Ghana, and other this musical apps, this Spotify has become so popular among the youngsters, and much like how Netflix uses machine learning, the Spotify also uses it the same way. With the weekly releases, it gives you a list of around 30 songs and which you should listen to. And then it would directly make it as a playlist and send it to users of these songs. And they are, okay, it sends it, and all the songs are picked up by machine learning algorithms because it sends you a list of 30 songs. If you hear those songs, then all these songs, they are picked by the machine learning algorithms. It has learned that you are hearing these songs. So this analysis of your activities, and then it matches with your taste. Machine learning models, they come to know that what is your taste, and from the songs you have listened in past, it will recommend the new songs. So Spotify is also using the machine learning, right? Facebook, all of you know, Facebook is also using machine learning for several different tasks. You have experienced that Facebook automatically reflects faces and suggests friends tag when you are trying to upload photos on Facebook, right? Now, Facebook uses AI and ML to identify faces. Facebook uses AI to personalize news feed, and it also makes sure to reflect posts that entertain you. So this is all is achieved using machine learning. It shows advertisements of a particular business that are relevant to one's choice also. So this is all done through machine learning, right? The next example is Pinterest. It uses machine learning to automatically recognize objects in the images or pin those objects and then recommend similar pins, right? So these are all popular applications which you are using in your day-to-day life. Snapchat, it also uses machine learning. You know for what it uses machine learning? It offers facial filters, right? That filter and track facial activities, and it permits users to tag animated images or digital masks that shift when their faces move. This is also using machine learning, right? Instagram, it also uses machine learning, right? With the help of machine learning algorithms, sentiments behind the emojis can be identified on Instagram. And Instagram can make and auto recommend emojis and emojis hashtags. And there is a massive, use of emoji across all demographics that are used to describe and explore by Instagram at a massive scale through emoji to text translation. So this all has been possible because we are generating a lot of data daily on this social sites. So using this lot of data, those companies, they have made machine learning models. Those models they learn, and they improve their services using those data which we are generating. The next reason is improve decision making, right? Machine learning can be used to make better decisions in industry by making use of various algorithms, right? So for example, machine learning is used for accurate disease diagnosis, to forecast weather, to forecast values in stock market, to predict downfalls in the stock markets, to identify risk and anomalies, etc. So this decisions can be improved using machine learning. So this is also one of the reasons why machine learning is so popular today. The next is it is used to discover patterns and trends in data. Patterns are everywhere, right? It belongs to every aspect of our daily lives, right? Just we need to observe them. Starting from the design and color of our clothes to using intelligent voice assistants, everything involves some kind of pattern, right? Because everyone's voice is different. They have some, everyone's voice has some pattern. The design and color of our clothes, they are also different. We like different colors, we like different clothes. So patterns are everywhere. So let us see an analogy here. I think I gave this analogy. I don't remember whether I discussed this analogy in last class, last session or not, because I covered it quickly. Suppose when we are in school, we were often given a task of identifying the missing alphabets. Suppose you are given a sequence of alphabets and there are some missing alphabets in the sequence, and you are asked to identify the missing alphabets. Or suppose in school you are asked to predict which number would come in the series next, right? We know various series, Fibonacci series and some other series are there. So suppose you are asked to predict the number in the series, or suppose you are asked to join the dots for completing the figure, right? So when we were in school, we were asked to complete all this, and the prediction of the missing number or alphabet involved analyzing the trend followed by the given numbers or alphabets in the given series or in the given data. And this is what pattern recognition in machine learning exactly means. This is what is done by machines when they perform pattern and trend recognition. It is similar to what we did in our school, right? The patterns can be discovered physically, mathematically, or by using the algorithms, right? So we know how to recognize those patterns physically, manually, right? And we can also use algorithms to predict these patterns. And when we talk about pattern discovery in machine learning, it indicates the use of powerful algorithms for identifying the regularities in the given data, right? So finding hidden patterns and extracting key insights from data is the most essential part of machine learning. And by building predictive models and using statistical techniques, machine learning allows us to dig inside the data at very minute level also. So this is a reason. So that's why we need machine learning. And the next reason is, these are the four most reasons, right? And the next reason is to solve the complex computational problems, we need machine learning, right? So from detecting the genes associated with the diseases to building self-driving cars, machine learning can be used to solve the most complex problems of our real life, right? So this is why we need machine learning today. These are the needs of machine learning. Let us now see how machine learning has evolved. This might have covered in your previous sessions, but with respect to today's session, I need to discuss this briefly, that how machine learning has evolved. Here again, I would give you few more examples of machine learning. Everyone knows AI today, right? I do not need to throw much light on this part. Artificial intelligence, it is a branch of, we can say, computer science, which has the potential to analyze complex data. And sometimes it is called machine intelligence because it is an intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans, right? So AI is technique that enables computers and machines to mimic human intelligence using logic, if-then rules, decision trees, and machine learning. So that is what AI, right? These are the subdomains of artificial intelligence, and subdomains of AI research include reasoning, knowledge representation, machine learning, natural language processing, etc. And among these subdomains, machine learning is one of the popular and widely used subdomain. Right? This ML was not so popular earlier. Here you can see in this diagram that it was invented in 1980s, right? This machine learning term was first coined by Arthur Somel in year 1959. In 1959 means before this it was introduced, but then it was known to people. It became popular since 1980s, right? But then we were not using at that time this machine learning for the applications. We were not using it much, right? In earlier days. But today we are using machine learning in most of the sectors because today we are generating a lot of data. Earlier we did not have this data in digital form, and that's why though machine learning was there, we were not able to make use of those algorithms to derive insights because we were not having data in digital form. Today we have data in digital form, and that's why this machine learning and deep learning algorithms have been so popular, right? So this machine learning is a subset of artificial intelligence. As you can see in this diagram, it is a subset of artificial intelligence that includes statistical techniques which enable machines to improve at tasks with experience, right? And machine learning is used anywhere today for automation. You may already be using a device that utilizes machine learning, but you might not be knowing that that device or application is using machine learning. For example, you might be using fitness tracker, Fitbit, MI Fitbit or some other Fitbit. You might be using it, right? Then it includes machine learning. Suppose you might be using intelligent home assistant like Google Home or Amazon's Alexa, but they are also using machine learning. And these are not only the examples of machine learning, there are much more complex examples of machine learning in real life, right? Okay, so this is about the machine learning. Deep learning, which is not the focus of today's session, but let me tell you what is deep learning. It is the subset of machine learning. It comprises of algorithms that permit software to train itself to perform tasks like speech and image recognition, and it uses multi-layered neural networks to vast amount of data. It uses multi-layered neural networks. So architecture of neural network for deep learning is quite complex compared to architecture of neural network for machine learning. Right? I'll not discuss this in much detail. Okay, so what exactly the machine learning is, how it works, right? As you can see in this figure, machine learning process begins by feeding the data to machine. The lots of data is fed to machine. Then machine uses this data and machine gets trained to detect hidden insights and trends using this data. And these insights are then used to build a machine learning model by using machine learning algorithm in order to solve a problem, right? So machine learning provides machines the ability to learn automatically, and it improves from experience without being explicitly programmed. So this is important part of machine learning, that it learns automatically and it improves experience without being explicitly programmed, right? So it is like when we were kids, and suppose when kids are given a basket of fruits, and if they are asked to identify that the name of fruit, or if they are asked to tag each of this fruit, then initially they don't know anything, that whether which is orange, which is cherry, which is apple. But over the period of time, when they grow and when they observe the things around them, they learn. Sometimes they learn from parents, sometimes they learn from friends, sometimes they learn from teachers, and sometimes they learn from their own. But through observation and analysis, sometimes they learn their own, that which is orange, which is apple, which is cherry, right? So this is how machine learning works. Okay. To give you a better understanding of machine learning and its significance, here I have included a couple of real life sectors wherein machine learning has brought technological advancements, and I have also included a couple of daily life applications. These are the daily life applications. These are the sectors: manufacturing, healthcare, finance, customer services, transportation. We have seen examples for transportation, manufacturing, healthcare. It is also used in e-commerce, automobile, right? Self-driving car. In e-commerce also we have seen. So these are some of the real life sectors. Otherwise, it is also used in education, in your education, agriculture, right, etc. And these are some real life examples. You know that these applications, they use machine learning, right? But you must be knowing that for what jobs, to provide which services, they are using machine learning, right? Everyone knows that search engines, they use machine learning. Google search engines also uses machine learning. But for what it is using machine learning? Google search engine, it improves machine learning to Google search engine uses machine learning to improve answers to queries, to recognize speech, right? You know that you can also search, you can use Google Assistant, and it captures your speech and it gives you answers to your queries, right? So it recognizes your speech and it recognizes your speech, your language using machine learning. It is also able to translate languages between 100 plus, it is able to translate between 100 plus languages, right? Search engines. You can translate from English to Hindi, English to Gujarati, English to Tamil, right? So this is possible. So this is also Google service provided using machine learning, right? For example, Google supports search by picture. I don't know whether you have tried it or not, but you must be knowing that Google also supports search by picture, right? Generally, you search in Google using text. You type your query and Google search engine provides the result. But if you have not tried the Google search engine to search by picture, then you may try. You can use this URL images.google.com. so it will ask you to upload the image. You may upload the image and it will provide the results, right? So this service by Google, it is using machine learning. The service of search by picture, it is also using machine learning. Back in 2013, it was reported that I don't know whether you remember this website or not, Flickr, where we used to upload our pictures, right? So I'm talking about 2013 because latest statistics are not available with me. So I have statistics of 2013. It was reported that Flickr users, they were uploading 1.4 million photos per day. 1.4 million photos per day, right? Instagram users, they were uploading 40 million, so almost 40 times, because Flickr 1.4 million, Instagram 40 millions, right? So they were on Instagram, we were uploading 40 million per day, and on Facebook, we were uploading 350 million. I'm talking about 2013, right? Now, while these statistics have likely gone up today, right? It is difficult for me to find recent data, so I included this. It shows that the volume of photos that need to be cataloged and analyzed on the web daily is very huge. This volume is huge, right? And this volume can be analyzed efficiently only with machine learning, right? And this task is perfect for machine learning because it can analyze color, it can analyze shape patterns, and it can pair that with any existing schema. It can pair image with any existing data about the photograph to help the search engine understand that what an image actually is. So these are some services I have discussed that for what the machine learning is used by the search engines. Email programs, you know, so I may skip this, that email programs, the Google spam filter is the example. We can say that it uses machine learning. Gmail makes use of machine learning to filter spam and non-spam, emails, right? I'll not discuss it in depth. Banks use machine learning to predict exchange rates. They use finance company, they use to predict stock markets. They use machine learning to predict loan amounts for customers, etc., which also was discussed in last session. Smartphones, this example was not discussed. Smartphones, they use machine learning to recognize objects, to recognize your faces, to recognize gestures, to recognize your voice, to recognize music, right? Have you ever thought that how the smartphone is recognizing all these things, right? Your smartphone camera, it is used to recognize the objects. It is used to recognize your faces. And if you have noticed now, these days, on backside of some of these smartphones, you will see a label, AI enabled camera. AI enabled camera, right? So what they are using machine learning on, right? So the smartphones, even Facebook's auto tagging feature, that auto tagging feature, it is also machine learning applications, right? It is Facebook's DeepMind face verification system. Its name is Facebook DeepMind face verification system, which is based on machine learning. Robots, they use machine learning to localize themselves, and they use machine learning to identify obstacles. Autonomous cars, they use machine learning to drive, to recognize obstacles, to recognize objects, etc. The video games, right? You are playing video games on your mobile phone and other smart devices. These video games, they use machine learning to enhance the player's experience. To enhance player experience. Every time you play this game, machine learning algorithm learns your moves, right? Your behavior, your patterns, and it improves, right? And next time you will get improved service. Adaptive telescopes, they use machine learning to improve image quality. And in healthcare also, I discussed some applications in healthcare too in last session, so I may skip this. So these are the applications of machine learning, right? Okay, now this is the terminology related to machine learning. So before we discuss supervised and unsupervised concepts, it is clear the terms which are associated with machine learning. Undoubtedly, terminology helps us to understand any topic better. So before we understand the machine learning workflow, machine learning process, let us comprehend some terms associated with this machine learning. The first is algorithm. Machine learning algorithm, it is a set of rules and statistical techniques that are used to learn patterns from data and to draw significant information from it, right? So they are the algorithms. It is logic behind machine learning model, and the examples of machine learning algorithms are linear regression algorithm, decision tree, polynomial regression algorithm, support vector machine, etc. These are the examples of algorithm. The next term associated with machine learning is model. It is the main component of machine learning, we can say. It is trained by using a machine learning algorithm, right? It is trained using the machine learning algorithm, and algorithm maps all decisions that a model is supposed to take based on the given input in order to get the correct output. So that is model. Yeah, these are two important terms to understand: predictor variable and response variable. Predictor variable is a feature, or they are features of data that can be used to predict the output. They are the features, or there is a single feature that is used to predict the output. Predictor variables are the features of data which are used to predict the output, right? Response variable, it is the feature or the output variable that needs to be predicted by using the predictor variables. So this is we can say this is input variable and this is output variable, and this output variable is predicted based on this predictor variables, based on this input variables. Yeah. Now the remaining three terms are related to data set. The remaining three terms are related to data set, right? The data set, it is divided, you can say that see that in three parts: training data, validation data, and testing data. This is also a core part of machine learning. Machine learning model is built using this training data. The model sees and learns from this data, and training data helps the model to identify key trends and patterns essential to predict the output. So this data, this all data, it consists of this predictor variable and response variable. They consists of for supervised learning, I'll discuss at that time that they consists of two variables, predictor variable and response variable for supervised. And for unsupervised, we have only input data. We don't have labels, right? Validation data, the validation set is used to evaluate a given model. It is used to evaluate the given model, and the model is typically evaluated frequently. Model is typically evaluated frequently. We as machine learning engineers, we use validation data to fine tune the model hyperparameters. So model occasionally sees this data, but never learns from this validation data. Because as I have told you, we frequently validate our model. So frequently our model sees this data, but model does not learn from this data. The validation set results are used to update higher level hyperparameters. That is the aim of this validation set. And validation data set is also known as development set. It is sometimes known as development set. And this name makes sense because this data set helps during the development stage of this model. And that's why it is also known as development set. And the last term related to this machine learning concept is testing data. After the model is trained, it must be tested or it must be evaluated that how accurately it can predict the outcome, right? For a new input, how accurately it can predict the output, that must be evaluated. And this is done by the testing data set. It is only used once a model is completely trained. It is used once the model is completely trained and evaluated with validation data also, because as I've told you, validation data is used to tune your model's parameters, right? So after that, we use the testing data. Many a times the validation set is used as the test set, but it is not good practice. This validation set is used as testing set, but it is not good practice. The test set is generally well curated, and it contains carefully sampled data that spans the various classes, because we have to evaluate the trained model for all the classes, right? So the test data contains carefully sampled data that spans the various classes that the model would face when used in the real world. So they should not be mistaken. They are different, right? And validation set should not be used as testing set.
Ma'am, can I ask one question?
Yeah.
Sorry, you are coming to that point. Sorry. Okay, Sunny, thank you, ma'am.
Oh. So now you know which different data sets are used for ML model, that training, validation, and test data set, right? So question may arise to your mind that how to divide the collected data into train, validation, and test set, right? So division of data into these three sets mainly depends on two things. Main two things are there. First, the total number of samples available in your data set. And the second point is the actual model you are training, that which model you are training, right? So depending on this, we can decide the ratio for training set, validation set, and testing set. Some models, they need a large amount of data to get trained. And so for this models, you can select the larger training set if they need a large amount of data. And models with very few hyperparameters will be easy to validate and tune. So you can probably reduce the size of validation set. But if your model has many hyperparameters, you need to have a large validation set as well. And if you have a model with no hyperparameters or ones that cannot be easily tuned, you probably do not need a validation set, right? So it depends that if there are more number of, because I discussed here right? That it is used to tune the hyperparameters. So if there are more hyperparameters in your model, right, you need a large validation set. If there are less, then you need less amount of samples in validation set. And if there are no hyperparameters, or it is difficult to tune those hyperparameters, then probably you don't need a validation set. So like many other things in machine learning, the ratio of train, validation and test division is also quite specific to use case, and it will be easier for you to decide upon the division ratio as with practice over the period of time. As you train and build more and more models, right, you will be familiar that what should be the ratio for these three different sets. Okay, fine. Okay, then this is the machine learning process, machine learning workflow, which is similar to data science process which we discussed in last session. Some steps you will find similar, because as I told you in last session, machine learning and data science, they go together, right? Machine learning process involves building a predictive model that can be used to find a solution for a problem statement. So the very first step is define the objective of the problem statement. This is the very first step. And at this step, we must understand that what exactly need to be predicted. For example, our objective may be to predict the possibility of rain by studying the weather conditions. So objective must be clear, that what is our object, whether we want to predict the temperature of tomorrow's temperature, or whether we want to predict the possibility of rain by studying the weather condition, etc. Right? Okay, the next step is after once you have a clear objective for your problem, the step is data collection. At this stage, we must be asking questions such as what kind of data is needed to solve this problem, is the required data is available or it should be collected, how it should be collected, if it should be collected. So such questions are asked, and once you know the types of data that is required, data can be collected using any of the data collection technique which we discussed in last session. The next step is data preparation. The data you collect is almost never in right format, so you will encounter a lot of inconsistencies in the data set, such as missing values, redundant variables, duplicate values, etc. So removing such inconsistencies is very essential, because they might lead to wrong computations and predictions. So that is the next step, which is also similar to data science step, right? Okay, now this is choosing learning algorithm to build a machine learning model, right? So an appropriate learning algorithm is required to be chosen to build an effective machine learning model. For example, we want to build a model to predict rainfall, then in this case, output will be true or false, because there would be rain, yes or no. Tomorrow it would be raining or not. The output will be yes or no. So in this case, we can we can consider this as a simple classification problem, and we can use logistic regression. So you need to understand your problem, you need to analyze your problem, decide the objective, and accordingly, you have to choose an appropriate learning model. Choosing the right algorithm depends on three things. Remember this. You should remember this, that because if you choose any model to build your machine learning model, you may not get accurate results. So it depends on the type of problem you are trying to solve. The second factor is the data set you are using and the level of complexity of the problem. So based on these three factors, you should choose the right algorithm for you to right machine learning algorithm to solve your problem. The next is, once you build a model, right? This may be the new steps which were not there in data science process. Train model with training data. Train model. This step involves splitting the data into two parts generally. Training data and testing data, and training data will be used to build and analyze your model, right? The next step is model evaluation and optimization. After building a model by using the training data set, the model is evaluated. See, I'm saying that using training data set, the model is evaluated. Actually, it is validation set from training data set, right? So that is used to validate your model. The model is evaluated. Then after that model is evaluated using test data set to check the efficiency of the model and how accurately it can predict the outcome. Once the accuracy is calculated and any further improvements in the model can be implemented at this stage once you calculate the accuracy, right? And methods like parameter tuning, cross validation, they can be used to improve the performance of the model at this stage, right? And the last step is prediction. Now your model is ready, right? So once the model is evaluated and also improved at the previous step, it is finally used to make prediction. It is used to make predictions, and the final outcome can be categorical variable like true or false, or it can be a continuous quantity like predicted value of temperature or predicted value of stock market, right? So this is all about the machine learning process, right? That how it goes from starting to end. Okay, so that was the basics about the machine learning. Okay. Okay, now it's time to learn about the different ways in which machines can learn. And there are three different ways in which machines can learn: supervised learning, unsupervised learning, and reinforcement learning, right? Okay. So now let's see the second part of today's discussion, that is supervised and unsupervised learning. Okay. Supervised learning, as you know, it is a technique in which we train our model, machine learning model will label data, right? And this supervised learning algorithms, they are most commonly used machine learning algorithms for solving the problems. They take the training data and its associated output during the training process. Here you can see that we discuss this terms: input variable, which is known as predictive variable; output variable, known as response variable, right? So it takes this training data. It consists of input variable and output variable, right? The main objective here is to learn an association between this predictor variable and response variable. And using this sets of variable, we generate a function, this kind of function that maps inputs to desired outputs. Right here, you can see that function app maps input variable to desired output variable. And the training process, it continues until the model achieves a desired level of accuracy on the training data, right? Okay. So, for example, here you can see that A and B, they are input and output variables, and we apply an algorithm to learn this mapping. Any supervised learning algorithm can be used to learn the mapping function from the input to output. And the main objective would be to approximate the mapping function so well that even when we have new input data, if we have new A, we can easily predict the output variable B for that new input data. Based on machine learning tasks, the supervised learning algorithms, they can be divided into two broad classes: classification and regression. And examples of supervised machine learning algorithms, they include decision tree, random forest, logistic regression, KNN, etc. In this figure, you can see that we are feeding machine with spam and non-spam emails, right? And the goal for the machine is to classify the emails into two groups. Classify the emails into two groups, that is spam and non-spam. That is the goal, right? The training data set that is fed to this model, it is labeled. This is the training data set. So they are labeled that it is not spam and this is spam. So once it is trained, the trained model can be used to for the new email, that whether it is spam email or it is non-spam email. The next is unsupervised learning. As the name suggests, it is opposite to supervised machine learning algorithms. Unsupervised learning involves training by using unlabeled data, and it allows model to act on data it allows model to act on data without guidance. We don't have any response or output variable to predict here, right? As we have in supervised learning, we don't have output variable here. So we have input variable here. So suppose we have a input variable A, then there would be no corresponding output variable, and the algorithm need to find the interesting pattern in this input data. Right? It is usually used for clustering population in different groups. For example, it is widely used for segmenting customers in different groups by their purchasing behavior, right? It is used for segmenting customers by e-commerce companies, by financial companies, etc. And based on the machine learning task, unsupervised learning can be divided into three major categories: clustering, association, and dimensionality reduction. Segmenting customers in different groups by their purchasing behavior is the example of clustering. Example of association is market basket analysis. When you analyze customers' shopping behavior, right, then it is based on association rules. And dimensionality reduction, we can say the example of anomaly detection. It is the example of dimensionality reduction. Examples of unsupervised machine learning algorithms include k-means clustering, a priori algorithms. These are popular algorithms in this category. And let's see one example that how unsupervised learning clusters the input data in different groups. Here you can see that we are feeding a set of cartoon pictures, and this unsupervised learning algorithm, it identifies prominent features of Tom, such as you can see that the Tom has pointy ears, big size, etc. So to understand that this image is of type 1, that is image here the category would not be Tom, Jerry, but the categories would be type 1 images, type 2 images, right? So this is type 1, right? And similarly, it finds such features in Jerry and knows that this image is of type 2, right? So these images, they are categorized, they are clustered in two groups, right? Type 1 and type 2. And it learns automatically, it learns on its own from these pictures. It classifies the images into two different classes without knowing who is Tom and who is Jerry, because no labels have been provided here that who is Tom and Jerry, but it classifies them in different groups. Okay. Reinforcement learning. Will not go in detail about reinforcement learning, but let me briefly explain that what is reinforcement learning. It's not a focus of today's discussion. Using reinforcement algorithm, the machine is trained to make specific decisions. Machine is exposed to an environment where it trains itself continuously using trial and error. This is important to know that these algorithms, they train themselves continuously using trial and error. This machine learns. Machine learns from past experience and tries to capture the best possible knowledge to make accurate decisions in future. This type of machine learning is comparatively different from supervised and unsupervised learning. If you are okay, let us take one example and then let's try to understand the concept of reinforcement learning. Imagine if you are lost or if you are dropped off at the isolated island. What you would do? Initially, You panic. Yes, of course, we panic, right? Initially, we would, but as time passes, you will learn how to live on the island. You will explore the environment of that island. You will understand the climate conditions over the island, the type of food that is available on the island. You will also be familiar with the dangers of the island. So you will have exposure to environment on island as time passes. This is exactly how reinforcement learning works. It involves an agent, right, that is put in an unknown environment. It's like you are lost you are dropped off on an island. This is an agent. agent is agent agent is exposed to an unknown environment where agent learns by observing and performing actions that result in rewards. So reinforcement learning is mainly used in advanced machine learning, and there it learns receiving rewards and penalties. Here you can see in this example, this is agent exposed to unknown environment. There are two different paths. This is say safe path, and this is not safe path because fire is there on this path. So this is safe and this is not safe. But initially, agent does not have any knowledge that which is safe and which is not safe. So agent may select this path, right? When agent follows this path, when agent reaches this point, agent comes to know that this is not safe path, and agent may receive penalty. So agent has learned that which kind of path is not considered safe path, right? And it has learned that it should have followed this safe path, another path, right? So this is how it learns from experiences. And reinforcement learning, it is mainly used in advanced machine learning areas such as self-driving cars, where it learns with experience. To better understand the difference between the supervised, unsupervised, and reinforcement learning, I recommend that you go through this short video which is available on Edureka. This video is of almost 20 minutes, but nicely they have explained the difference between uh, supervised, unsupervised, and reinforcement learning. So I'm not playing this video here, but later you can watch this video and you can understand the difference between this. I have just introduced the difference between all these three concepts. I have not gone in depth. Okay. Now, these are the different types of algorithms available in each category. In supervised algorithm, in supervised category, we have regression algorithms, we have decision tree algorithms, we have random forest classification algorithms. These are different classification algorithms, right? Similarly, in unsupervised, we have clustering, association analysis, and hidden Markov model, right? So these are the different algorithms available in this different machine learning category, right? In clustering, we have this SVD, PCA. PCA, I think you learned. I noticed that you have learned this PCA, principal component analysis. SVD is singular value decomposition. You may find more clustering and regression classification algorithms in literature, but these are very popular. They are they are useful to solve several real life problems. So these are the different algorithms. But as I have told you, the focus of today's discussion is supervised and unsupervised learning, specifically regression and classification algorithm. So I'll not focus on this part also, and they may be covered by Dr. Priyank or Dr. Godwin, but my focus is on this part, classification algorithms. Okay, so let's see what is classification problem. What are classification problems? It's a classification problem. Let's first see what is classification. Classification is a process of categorizing a given set of data into classes. You are given suppose you are given shapes and you are asked to differentiate these shapes. You may be given fruits and you may be asked to separate the fruits, right? You may be given different objects and you may be asked to separate them. So classification is a process of categorizing a given set of data into classes. It can be performed on both structured or unstructured data, right? In last session, we see what is structured and what is unstructured data. The process starts with predicting the categorical class labels of new instances based on past observations. And class of given, and the classes are often referred to as target or label or categories. These words are used interchangeably in literature. They are sometimes called classes, they are called categories, they are called labels, they are also called target, right? Here you can see in this example that what exactly the classification problem is. You are given a set of n attributes. The attributes may be ordinal or categorical. Along with the set of n attributes, you are given a set of m classes and a set of label training data, right? You are given a set of n attributes, means they are variables. These are also, we use synonyms for this attributes. They are sometimes called features, they are called variables, they are called columns, right? So we are given a set of n attributes, set of m classes and set of label training data. So this is the set of label training data. Right? Now each pair, it consists of two variables. This is predictor variable and this is output variable. Right? If you remember, we discussed that these are the variables, predictor variable and output variable. Right? Okay, now this is the set of attributes. There are n attributes. So these are n variables, n attributes are there for input variable. You can also say that this is input variable, this is output variable. So this is your training data. Each input variable, each input variable consists of n attributes. So these are the n attributes V1 to Vn, right? And this is label associated with this input variable. This is label, this is target, this is category or class. So this class, it belongs to this set of class. I told you that we are also provided a set of m classes. So these are the m classes. So this would be any one of these m classes, right? I hope you understand this. Okay, so this is given to you and we have to determine a classification rule that predicts the class of any input data from the values of these attributes. If we input A, the model has to predict B. Based on this class will be predicted by the model, right? From the attribute values. So this is classification problem. There are three main types of classification problems. Binary classification, actually in literature you may also find that there are major two categories, binary classification and multi-class classification. But this third category is also considered in some research, that is multi-label classification. Binary classification is a type of classification with two outcomes. For example, the outcome may be true or false, right? And the typical example is just we discussed one example of email spam detection. With each email, the output would be either 1 or 0. Maybe 1 represents the spam email and 0 represents it is not spam email, right? So it is binary classification example. Another example is disease diagnosis. Suppose we want to identify from the X-ray that patient is suffering from corona disease or not, right? To chest X-ray is considered. Now output would be either 1 or 0. So maybe 1 represent patient is suffering from corona disease, 0 represent patient is not suffering, patient is healthy, not suffering from corona disease. So these are binary classification problems. Multi-class classification problem, the classification with more than 2 classes. In multi-class classification, each sample is assigned to one and only one label or target, though there are multiple classes, right? Each input is assigned only one label, but there are multiple classes. For example, suppose we want to classify shapes, then definitely we may have multiple classes. We can have multiple classes like circle, rectangle, triangle, hexagon, triangle, right? We may have multiple classes. Okay, another example of multi-class classification is, suppose you want to distinguish or you want to recognize handwritten character, handwritten digital character, let's say handwritten digital character, handwritten digits. So they are 0 to 9, right? So we can have total 10 classes, 0 to 9. So these are the examples of multi-class classification. If you want to recognize alphabet, then we will have 26 classes. Okay. Okay, the next is multi-label classification. This is a type of classification where each sample is assigned to a set of labels or targets. Each sample can have multiple labels, right? For example, let me give you a very simple example. You are feeding a color image to your machine learning model, which contains shapes, color shapes. So you want your machine learning model to identify the shape as well as the color of that shape. So maybe it may have, each input may have two tags, two labels, that the shape is triangle and the color is yellow, right? The shape is circle, the color is red. So this way you have multiple labels also. So this is multi-label classification. Let us now see a representative example to understand the binary classification, which is very common for a majority of the problems. Suppose there are two classes, right? These two classes are circles and this crosses, and there are two features, x1 and x2. The model is able to find the relationship between the features which are x1 and x2 of each data point and its class, and to set a boundary line between them. Model is able to set a boundary line between these two classes. So when model is provided with the new data, it can estimate the class where it belongs, given its features. So for example, suppose this is a new data, right? Then through the features x1 and x2, the model will be able to estimate the class of this new data, that it belongs to this class. In this case, new data point falls into subspace of circle, right? And therefore the model will predict that its class is to be a circle of this new data. It is also important to note that not every classification model will be useful to separate properly different classes from a data set. Every classification model is not able to draw a line between two classes. Some algorithms, like the perceptron, right, which is based on a basic artificial neural network. Perceptron you might have learned, right? You know what is perceptron. So perceptron will not converge when learning the model's weights if the classes cannot be separated by a linear decision boundary, right? So some of the most typical cases are represented in this diagram, right? That this is linearly separable, this is not linearly separable, this is not linearly separable. So the point here is the task of selecting an appropriate algorithm for your classification problem became of supreme importance in classification problems. It's very important, right? You cannot use any algorithm, right? You have to choose a proper algorithm so that you will be able to create the separate classes for your given data set. These are the types of classification problems. Now, these are the various algorithms that can be used to solve the classification problems. In practice, it is always recommended to try and compare different algorithms' performance. It is not suggested that if problem is that for a particular type of problem you should go for logistic regression or SVM or decision, right? You need experience over the period of time. When you build more and more models, you will be experienced and you will be able to determine appropriate model for your problem. but it is always recommended that you try and compare different algorithm performance in order to choose the most appropriate algorithm to tackle your classification problem. The performance is because greatly influenced by the data available, the number of features, the number of samples, the different classes available in your data set, whether they are linearly separable or not. So all these factors are considered, and the performance depends on all these factors, and so you cannot randomly choose any classification algorithm. You have to try different classification algorithms, and you can choose best fit algorithm. Okay, now let's see these algorithms, not in detail, but let me introduce these algorithms because uh, uh, in-depth discussion of each of this algorithm may require a half day or full day because these are huge concepts. They cannot be fully covered in this stipulated time. So I'll not cover them in depth, but I'll introduce them, right? Logistic regression, though you have already studied this, I have included it here because it is one of the most used algorithm to tackle binary classification problem. It is a simple but powerful classification algorithm. It works very well on linearly separable classes, and it can be extended to multi-class classification problem also. If you want to use it for multi-class classification problem, you have to you have to use OVR technique. I don't know whether you learned this OVR technique or not. That what is this OVR technique? OVR stands for one versus rest. OVR stands for one versus rest. It is also referred to as one versus all, and that's why sometimes it is called OVA, OVR or OVA. It is a heuristic method for using binary classification algorithm for multi-class classification. As I told you, logistic regression is preferred for binary classification problem. If you want to use it for multi-class classification problem, then you can extend its applicability by using this OVR heuristic method. Algorithms such as perceptron, logistic regression, and support vector machines, they were designed for binary classification, and they do not natively support classification tasks with more than two classes. So heuristic methods can be used to split the multi-class problem into multiple binary classification problem. When you extend their applicabilities for multi-class classification problem, what we do, we split the multi-class problem into multiple binary classification problems. A binary classifier is then trained on each binary classification problem, and predictions are made using model that is the most confident, right? For example, suppose we are given a multi-class classification problem with three classes, red, blue, and green. It's a multi-class classification problem because there are three labels, red, blue, and green. Now this could be divided into three binary classification data sets or three binary classification problems, and these are the three binary classification problems. Red versus this group, blue versus this group, green versus. So for this binary classification problem, the output may be 1 if it is red and output may be 0 if it is not red, right? Then we do not bother that which is the other color. Similarly, this is another binary classification problem, that whether it is blue or other color. If it is blue, the output may be 1, and 0, then it may be other color, right? So multi-class classification problem here, it is divided into multiple binary classification problems, right? And then we can use this logistic regression. Okay, SVM, it can be considered as an extension of the perceptron algorithm. In SVM, the optimization objective is to set a decision line, right? Actually, this is the example of SVM only. In SVM, optimization objective is to set a decision line that separates the classes by maximizing the margin between this line and the sample points that are closest to this hyperplane, right? And these points are called support vectors. These points are called support vectors. To set this is the example of SVM that we use the line with maximum margin to separate the two classes, right? To set the maximum margin, two parallel lines are here added. As you can see, two parallel lines are added, right? And we try to maximize their distances from the original decision line. And we consider the misclassified points here, which we can consider as error, misclassified points, right? And the points between the margins and the line. So normally decision lines with larger margins, they tend to have a lower generalization errors, and on the other hand, models with small margins, they tend to have tend to be less prone to overfitting, right? So decision line with maximum margin should be chosen to separate the two classes. These are points, they are called support vectors. This is positive hyperplane. This is negative hyperplane. This is decision boundary, right? This is margin. Okay. You will learn more about this SVM in Dr. Godwin's session. Okay, decision tree. The next is decision tree. It has many analogies in real life, and it has influenced a wide area of machine learning, covering both classification and regression. Decision tree algorithms, they break down the data set by making questions until they have narrowed down the data, until they narrow data enough to make predictions, right? For example, let's see the example. This is the example of a decision tree for deciding whether life is possible on a newly discovered planet or not, right? A new planet is discovered, and we want to determine whether life is possible over there or not. So there are n number of deciding factors when you want to know whether life is possible over there or not. So, and this n number of factors need to be thoroughly researched to take an intelligent decisions. These factors can be these are the different factors. These factors can be what is the temperature on the planet, whether water is present on the planet or not, whether flora and fauna survives the climate or not, right? Whether the surface is prone to continuous storms or not. So this kind of questions, this kind of factors may be considered to decide whether life is possible on newly discovered planet or not. Based on these features of the training set, the decision tree learns a series of questions to infer the class labels of the samples. Decision tree learns a series of questions to infer the class labels of the samples. And we can have classification rules which are the cases in which all the scenarios are taken into consideration and class variable is assigned to each instance. For example, we may have decision rules like if temperature is not between, there may be a specific range for survival. So let's say the range is XY, right? So if temperature is not between X and Y, then survival is difficult. If temperature is not between X and Y. If temperature is between X and Y, right? If temperature is between X and Y, and if water is not present, temperature is between X and Y, but water is not present, then survival is difficult. If temperature is between X and Y, and if water is present, if water is present, and if flora and fauna are not present, then survival is difficult. Right? So such several rules can be created, right? And these rules, they help us to infer the class name for the input instance. So you may have a certain set of rules from this tree structure. The maximum depth of this decision tree is the largest length from the root. This is the root to the leaf node, right? Large depth and then what? Generally, in some cases, you may have a large depth for this tree, right? Then large depth can cause overfitting, and small depth can cause underfitting. So later you can explore decision tree in depth to know what are the different ways to avoid this underfitting and overfitting. So it is said that you should not have a large depth also, you should not have small depth also, because they lead to overfitting and underfitting problems. The next is random forest algorithm, right? We can take break here, break of 10 to 15 minutes. Is it fine if we take break at this time?
Yes, madam. 15 minutes is okay?
Yeah, so let's take a break. 10 to 15 minutes, it's okay. Maximum 15
15
minutes.
minutes. 11:45 will be. Okay. Okay.
Yeah, 11. If we take this time, so if we take break,
So shall we start, madam?
Yeah, we can start, sir.
Yeah.
Okay, let me start, sir.
Okay.
Okay, so far we discussed three classification algorithms: logistic regression, SVM, and decision tree. Now let's briefly discuss random forest, KNN, and maybe bias. If we have a data set with like a lot of columns, lot of features, the decision tree algorithm usually tend to overfit, and it over complicates the model and the learning process if it is a large data set and if we are using decision tree. Right? Then we can solve this issue by selecting each column randomly from the data set, because data set may have n columns. So you may select each column randomly and you may make decision tree for that column. For each batch, for each column, you may create one decision tree, right? So such group of such trees, they create random forest. It is a forest which consists of several trees. This random forest, it works in 4 steps. It works in 4 steps. Let me tell you the 4 steps which are used in random forest algorithm. We first select random samples from a given data set. Random samples means we select a column, right? So we select them from a given data set. Then we construct a decision tree for each of them and get a prediction result from each decision tree. So this is one. These are the different trees. Here you can see that there are multiple trees, and we get a prediction, a result from each of this decision. This tree is saying prediction output variable or the predicted variable by this tree is class A, by this is class B, by this is class B, right? So different trees, they predict different output variable. Now, after predicting this output variable, perform a vote for each predicted result, right? Which different results, maybe there may be 26 classes A to Z, right? But out of 26 classes, suppose only 3 classes have been predicted by these different trees in forest. Only let's say 5 classes have been predicted by different trees in this forest, right? Now the vote will be taken that which class is predicted for more number of times, right? So we select the final result based on this predicted results by different trees. Prediction result, the final prediction result with the most votes is considered will be selected, right? So I hope this is clear to you that if 5 different classes have been predicted, then which class is predicted more number of times, that is considered as the final output, that is the final class, majority voting, right? So this is how random forest works. The major difference between this random forest and decision trees are random forest is a set of multiple decision trees, while decision tree has only one decision tree. And big decision trees may suffer from overfitting, but random forest prevents overfitting by creating trees on random subsets. So that's why it is recommended that if it's a big tree or deeper tree, then we should go for random forest instead of decision tree. On the other hand, random decision tree has advantage that they are computationally faster than random forest. And random forest is difficult to interpret, while a decision tree is easily interpretable and it can be converted to rules, right? And we just saw one example that how the rules can be created based on the decision tree. So the idea here is to develop an ensemble learning algorithm which will combine a number of weaker models to build a more robust one. That is the idea of random forest algorithm. The only hyperparameter that you need to tune in this random forest algorithm is the k, that is number of tree. K represents the number of trees. And normally the model will perform better with larger K, but it will increase the computational cost drastically when the K is larger. So this is the only hyperparameter we have set in random forest algorithm. Next, we have KNN, K nearest neighbors. This algorithm belongs to a special type of machine learning model that are frequently called lazy algorithms. Right? You can later refer literature, or you can explore this concept in more depth later. There is a group of there are some algorithms called lazy algorithms. So this KNN belongs to that category, and they receive this name because they do not learn how to differentiate the data set with an optimized function. Why they are called lazy algorithms? Because they do not differentiate between data set with an optimized function, but they memorize the data set instead. They don't learn, right? They memorize, they mug up the things, right? The name lazy algorithm also refers to the kind of algorithms called non-parametric. These are instance-based algorithms. They are characterized by memorizing the training data set, and lazy learning is a specific case of these algorithms. It is associated with zero computational cost during the learning because it does not learn. So there is no cost associated with learning. It memorizes the things. So that is KNN. And the example here I have included is then how the overall process of KNN goes. The overall process is like this. We can choose the number of K and the distance metric. We can choose the number of K. K represents the number of nearest neighbors. What is K? K represents the number of nearest neighbors. So we can choose the K and the distance metric. We can find the K nearest neighbor. First we choose the K, then we find the K nearest neighbor of this sample to classify. Suppose this is my new sample to be classified, right? And now if K is 1, if I have chosen K1, then I have to locate one nearest neighbor, right? It will locate one nearest neighbor. So this is the nearest neighbor, and it is, I mean, total number is 1. Total number of neighbors is 1. Okay. Then assign the class label by, okay. Okay. Now in case of 1, this class label will be assigned to this new sample, right? Now if K is larger, K may be 3, K may be 5, K may be more than that. Now in that case, what we do, if K is 3 and this is the new sample to be classified, right? Then the 3 nearest neighbors will be chosen. So which are the 3 nearest neighbor? 1, 2 and 3. So that's why this is the circle which encloses those 3 nearest neighbor. This is the circle which encloses one nearest neighbor, right? Now 3 nearest neighbors have been chosen. So 3 nearest neighbor, 1, 2 and 3. And these are the 2 different classes. Class 1, that is square, and class 2, that is triangle, right? So 3 nearest neighbors have. Okay, now the class labels of all those neighbors will be considered, and the class label which appears the more number of times will be taken for this new sample. So you can see here that these are in this 3, there are 2 class 1 samples and 1 class 1 sample. So the label of class 1 will be assigned to this new sample, right? So this is how KNN works. The algorithm finds those K samples that are closest to the point to classify, basing its prediction on the distance metric. And the main advantage of it is that it is a memory-based algorithm. It adapts to new training data. This is the advantage. Because it does not need to learn. It has to simply remember that, right? So it adapts to new training data easily. And the disadvantage of this algorithm is that the computational cost increases linearly with the size of the training data. So this is KNN. Naive bias, I observed that you learn, but let me briefly tell you what is naive bias algorithm and how it works. It is a classification technique based on applying bias theorem with a strong assumption that all the predictors are independent to each other. All the predictors are independent to each other. In simple words, the assumption is that the presence of a feature in a class is independent to the presence of any other feature in the same class. I repeat, the presence of a feature in a class is independent to the presence of any other feature in the same class. So it works on bias theorem, and I observed that you learned it in depth in previous session, so I'll not go in depth. I have not included its example here. Okay. So this is all about the different types of classification algorithms. These are not all. You can refer literature for more, but these are most popular, and this algorithm solve most of the classification problems. So they have been discussed here. These are the classification problems which have real life classification problems which have been solved using these algorithms. This is already discussed twice, so I am not. This is also discussed. Handwritten digital recognition. Digital recognition, the goal is to identify images of single digits 0 to 9 correctly. Right? Okay, this is new image segmentation. In image segmentation problem, it arises in several image processing problems. This image segmentation problem, arises in several image processing problems. So this is very important, and this problem is solved using classification algorithm. It is little more complex example of image processing, we can say. For example, the satellite image. I told you in last session that one satellite image, it is very big, and it is in generally exabytes, right? So satellite images are to be identified. For example, we have one satellite image, and this from this satellite image, model has to identify man-made and natural regions, right? So suppose we have a machine learning model which is trained to identify these two regions from the image, satellite image. For example, buildings, we know that they are man-made regions, and they can be labeled as man-made, and the vegetarian areas, the farms, right? They are natural regions. Oceans, they are the natural regions, so they will be labeled as natural. So this problem, the image segmentation, the recognition of identification and recognition of different objects or different parts of the image is considered as image segmentation and can be solved using classification problem. Right? The next is disease diagnosis. This is also classification problem. We can identify disease or tissue types based on the gene expression levels. So disease diagnosis can also be considered uh, as a classification problem. Face recognition, that also we discussed. The Facebook's deep mind recognition system. It recognizes, it identifies the faces. It is also classification problem, and fraud detection is also classification problem. So these problems have been solved using the algorithms which we just discussed. Okay. Now, apart from all these algorithms which we discussed, which we just discussed, artificial neural networks are most popular machine learning algorithms today, which are used for supervised as well as unsupervised learning. Right? We cannot skip this powerful algorithms. They are used for supervised as well as unsupervised learning. They were invented in 1970s, but they have achieved huge popularity due to recent increase in computation power, because of which they are now virtually available everywhere. Right? So computation power has also increased, and why this increased computational power is required? Because we have to we have to process huge amount of data with this artificial neural network. So when we have a huge amount of data, and when we have a larger pictures, when we have unstructured data, the architecture of neural network may be complex. They are the models formulated to mimic the learning capability of human brains. Learning in artificial neural network can be supervised and unsupervised, and application of supervised ANNs became imperative in a situation wherein it is very difficult to get labeled data set. And it is essentially a machine learning model that is used in unsupervised learning, and more precisely, it is more suitable for deep learning. Right? So machine learning process, how it learns through artificial neural network, how machines learn through artificial neural network. So that learning process using this artificial neural network is analogous to human learning process, right? you must be introduced this concept, but let me briefly tell you that as we all know, the brain is an incredible organ of our body. It consists of billions of neurons which are connected with each other via massive complex parallel network. They are connected with each other via massive complex parallel network, and these neurons, they build nervous system. These neurons in our nervous system, they have ability to send and receive signals. They also have ability to work in parallel, and that is why humans have ability to perform several tasks concurrently. Right? For example, suppose let's take the example. When you drive a car, you take judgment through your eyesight, you control accelerator and brake using feet, and you change gear using hand. So these are all three tasks performed parallelly. This is because our neurons in our nervous system, they can work parallelly. And that's why I said that they are connected with each other via massive complex parallel network. In general, you can say that humans, they can see, hear, smell, taste, and touch together. Right? This is because neurons can work parallelly. Let's see that, and okay, these machines, they also learn, they learn through artificial neural network, right? We learn through our biological neural network, they learn through artificial neural network. And how they learn, the learning process is also similar. The learning process is also similar. We know that kids learn through observation and analysis. For example, when they observe and analyze walking and talking style of the people around them, and they learn how to walk and talk. As kids grow, they go out and they hear more people, and their vocabulary increases, and that is their vocabulary increases, and we can say that their learning increases, and they be able to speak more clearly, and they be able to speak correct statements. So we can say that their speaking accuracy increases. So learning increases accuracies. So artificial neural network, they also work on the same concept. When they learn more, their accuracy increases. Right? ANN structure is similar to biological neural network, as you can see in this figure. Neurons in ANN are connected with each other, and they have ability to send and receive signals also. And we provide label data to these neurons to learn from the data. The structure of this neural network is quite complicated. In it, the data passes through several layers. Here you can see that this is simple neural network perceptron. This is multi-layer perceptron. So data passes through several layers of interconnected nodes, wherein each node classifies characteristics and information of the previous layer before passing the results onto the other nodes in the subsequent layers. Right? These are the different layers in architecture of neural network: input layer, hidden layer, and output layer. Input layer is the first layer of this artificial neural network that receives the input information in the form of various text, numbers, audios. It can be files, image pixels, etc. So input is given to this input layer. Hidden layers, all the middle layers are considered as hidden layers, and it can have multiple hidden layers. There can be single hidden layer also, as in case of perceptron, or multiple hidden, or it can have multiple hidden layers. And these hidden layers, they perform various types of mathematical computations on the input data and recognize the pattern that are part of this data, right? So these neurons, they perform mathematical computations. They perform mathematical computation on the input data to recognize the patterns. In output layer, we obtain the result that are obtained through rigorous computations performed by the middle layer. So here we get the output, right? So this is the structure, this is the architecture of artificial neural network. In neural network, there are multiple parameters and hyperparameters that affect the performance of the model. The output of ANN is mostly dependent on these parameters. Output of neural network mostly depends on these parameters. Some of these parameters, as you can see in this figure, are weights. These are the weights W1 to, this is W1 to WN. These are the weights. These are the biases. Then there is learning rate we need to get, batch size, etc. And each node in this artificial neural network has some weight, right? Each node in the network has some weight associated to it, and a transfer function is used for calculating the weights, weighted sum of these inputs and the biases. So we use the transfer function for that to sum up them. After transfer function has calculated the sum, an activation function obtains the result, and based on the output received, the activation function fires the appropriate result from the node, right? It fires the appropriate result from the node. For example, if the output received is say above 0.5, the activation function may fire 1, otherwise it may fire. If it is below 0.5, then it may fire 0 if it is a binary classification problem, right? So where we get true, false, or we get 0, 1. So we can have that if the value is above 0.5, the output may be 1. If it is below 0.5, it may be 0. And some of the popular activation functions you might have learned, they are sigmoid, ray loops, softmax, 10H, etc. So I'm not discussing them. We have to complete this in stipulated time. So I'll not discuss them in detail. Okay, based on the value that the node has fired, we obtain the final output, and then using the error function, after receiving this final output, using the error function, we calculate the discrepancies between the predicted output and the resulting output, that is between the output variable and input variable, and then we adjust the weights of this neural network through a process which is known as backpropagation. So through backpropagation, we reset the weight values. Okay, so this is about the artificial neural network and its parameters. And these ANNs, they are part of emerging area in machine learning known as deep learning. Right? I don't know whether you have got information on deep learning or not, but they are central part of this deep learning algorithms. These are the various types of artificial neural networks: formal neural network, radial basis neural network, sequence to sequence model, which is used to process the text, recurrent neural network. It is also suitable to for natural language processing, modular neural network, convolutional neural network, which are more suitable for image processing, right? So these are the different types of artificial neural network. And these are advanced artificial neural networks which we are using to solve the most complex problems in our daily life. Okay. Okay, after that, after discussing all the possible algorithms which can be used to implement supervised and unsupervised, this artificial neural network can be used to implement unsupervised models also. So after this, now I would like to discuss the popular tools that can be used to implement this algorithms, or we can say that can be used to implement machine learning models. Maybe it is supervised model, it may be unsupervised model. Unsupervised model. We can use several tools are available and we can use them. So these are some of the popular tools. You will find lot many tools in literature. Scikit-learn, PyTorch, TensorFlow, Veka, K9, Colab, Keras, RapidMiner. So many tools are available. Some of they are Python, some like Scikit-learn, PyTorch, TensorFlow, Keras. They are Python programming based. They are Python libraries to implement machine learning models. Among these tools, this TensorFlow has been very popular today. TensorFlow and Keras. Keras is more suitable to build deep learning models, and TensorFlow is also a good choice to build machine learning and deep learning models. So I would like to discuss this TensorFlow, which I usually prefer to implement machine learning model. This TensorFlow is a Python library. So let me give you I cannot cover all these tools, right? So many tools are there. I cannot cover them. But let me discuss the TensorFlow, which is growing. Its popularity is growing, and it has been used to solve several complex real-life problems in different sectors of real life. I'll show you the examples which have been solved using building machine learning models using TensorFlow. So let me introduce TensorFlow to you. TensorFlow, it is an open source machine learning framework. It is a library. This library it is mainly provided for deep learning, machine learning, and high performance numerical computation using data flow graphs. This is developed by Google Brain team with Google's AI organization. It comes with strong support for machine learning and deep learning, and it has many pre-built functions to ease the task of building different neural networks. It is used for both research and production at Google. It is used for both research and production at Google. It is open source software library for high performance numerical computation. I would like to show you that why it is highly useful for high performance numerical computation. And for this high performance computation only, it is based on data flow graph. It is released on November 9, 2015. So it has been almost 5 years. This TensorFlow has been released by Google team. It has flexible architecture that allows easy development or easy deployment of computation across variety of platforms, such as platforms that support CPUs, GPUs, TPUs. You might have heard GPU, graphical processing unit, and TPU may be new to TPU is tensor processing unit. So it has flexible architecture which allows deployment of computation across variety of platforms that support CPU, GPU, or TPU. Right? And this TPU is a programmable AI accelerator which is designed to provide high throughput of low precision arithmetic. So we can distribute the computation across several platforms. And TensorFlow provides API, Python API, as well as it provides less documented C++ API also. And this is the latest version of this TensorFlow 2.4.0. I have taken the slides of TensorFlow from my previous presentation, and let me tell you that within the span of 1 year, that was the presentation, the last presentation of TensorFlow was in perhaps June or September. So that time it was 1.4 or 1.16 earlier it was, and today it is 2.4. So almost every few months the TensorFlow is upgraded version. Yeah, I have taken this version from this site, so you can find the latest version on TensorFlow website. You can search on tensorflow.org. Okay, as I told you, TensorFlow supports this deep learning, machine learning, and high performance numerical computation using data flow graph. So this data flow graph, it is heart of this TensorFlow. It is heart of this. It performs fine. It is efficient because of this data flow graph. So let's see what is data flow graph in TensorFlow. In data flow graph, computations are represented as graph. So in this graphs, nodes, they represent operations, and edges, they represent tensors. So this is the simple example of data flow graph. They represent data dependencies between number of operations. These graphs, they represent data dependencies between number of operations, right? Let's see this simple example to sum the square of two numbers A and B. So you may have written this code to sum the square of two numbers A and B. First, you may compute A square, then you may compute B square, and then you can add this two values T1 and T3. T1 and T2. So how you will represent this computation in data flow graph, as I have just discussed, that data flow graph is used to represent computations. So this computation will be represented like this using data flow graph. As we have just discussed, nodes, they represent mathematical operations. So this is multiplication operation. So this node represents the multiplication operation, and this will be the input to this node, and a square will be computed. It will be output. So this is the output T1. Here there will be T2. T1 and T2, they will be added, and the output will be T3. So you can see that ages, they represent data, they represent tensor. Tensor I will discuss later. They represent data, and this nodes, they represent arithmetic operations. TensorFlow, they use this data flow graph for computation. TensorFlow operates on basis of computational graph, as just we have discussed. Nodes, they perform mathematical operations, and ages, they carry data. This is another example. Suppose we want to compute function f, which is a function of three variables a, b, c, and this is the formula to compute this function. So how we will compute this using data flow graph? So these are the three variables. Here you can see a, b, and c. These are the three variables. Now we will go as per the priority and precedence of these operators. So first b into c will be computed. So here you can see that this is, let's assume that this is node only, data flow graph. This is one node, right? So this node, what is the arithmetic operation of this node? Multiplication. So b and c will be multiplied, and output would be this, right? Then this would be added, this output would be added into A. So this is the node that represent addition operation. And these are the ages, they carry data. And this would be the output of this operation. And then this output will be multiplied with 7. So this node represent the multiplication operation, and final output would be this. So this is another example of data flow graph, that how they represent computations. So what are the advantages of using this data flow graph for computation in TensorFlow, because of which it has been highly popular? So these are the reasons that this data flow graph, they supports parallelism, distributed execution, they supports fast compilation, and they support portability. So how they supports parallelism? By using explicit ages, you can see that this is the graph, right? Or let's take the simple example. This is the graph, right? By using explicit ages to represent dependencies between operations, it is easy for system to identify the operations that can execute in parallel, right? For example, in this graph, you can see that T1 and T2, they can be computed in parallel because there is no dependency. T1 and T2, they can be computed in parallel. So data flow graph, it supports parallelism. It allows TensorFlow to make some computations in parallel, distributing those computations over different machines. Moreover, it supports distributed execution by using the same explicit ages to represent the values that flow between operations. It is possible for TensorFlow to partition your program across multiple devices, right, which are attached to different machines. So what they can do, they can partition. Here we can have a partition for this graph. This is a very simple example, but we can partition the graph in multiple subgraphs, and those subgraphs can be distributed over multiple machines which are attached with either CPU, GPU, and TPU, and the computation can be carried out in simultaneously. Computation can be carried out simultaneously, right? So for example, the same example, T1, T2, they can be computed on different devices. Okay, the next advantage is it supports faster compilation. TensorFlow uses XLA compiler. XLA stands for Accelerated Linear Algebra. It uses XLA compiler that can use the information in your data flow graph to generate faster code by fusing together adjacent operations, right? So this faster compilation is provided by it. And portability, the data flow graph is a language independent representation. This data flow graph is language independent representation of the code, right? So you can build a data flow graph in Python, store it in a model, saved model, and you can restore it later in C++ program for low latency interference, right? So it supports portability also. So these are the reasons why DFG is used for computation in TensorFlow. Okay, so now we know what are the data flow graphs and why does TensorFlow use data flow graph. Now let us understand tensors, the basic unit of TensorFlow. Then what is tensor, right? Tensor, okay, basic unit of tensor. Tensor is a general name of multi-dimensional array. It is a tensor. What is tensor? Multi-dimensional array is called tensor. Multi-dimensional array of number is called tensor. For example, we can have one-dimensional tensor because we can have one-dimensional array, right? In mathematics, it is called vector. This is a list of values, right? In programming language, you will say this is one-dimensional array. In programming language, you will say that, or in computer science language, you will say that this is two-dimensional array. In mathematics, we say that it is matrix, right? So they represent data, and this is also called 2D tensor. This is called cube. If it is a cube is considered as 3D array, right? And so on, right? I'll give this example later. Discuss this. Let's see some other examples. So this is 1D tensor. This is 2D tensor. This is 3D tensor, which is cube, right? Now you can also have a list of cubes, a vector of cubes, right? Then it becomes 4-dimensional tensor. You can also have 5-dimensional array. You can also have 5-dimensional tensor. So how? It is a matrix of cubes. It is a matrix of cubes. This is cube of cubes. This is cube of cubes. So thus you can have n-dimensional tensor because you can have n-dimensional array. So similarly, you can, because a tensor is nothing but array. So if you can have n-dimensional array, you can have n-dimensional tensor. Associated with each tensor, there are two attributes. Associated with each tensor, there are two attributes, rank and shape. Rank represents the number of dimensions in the data and shape represents the size of each dimension. So for example, here you can see that suppose this is one-dimensional array. It is vector, right? So what is rank? Rank represents the number of dimensions. So how many dimensions are there in this example? Only one. It is one-dimensional array. So rank is 1. What is shape? Shape represents the number of elements in that dimension. So shape is 5. Right? So this is rank, and here I have included some more examples for rank and shape. Right? Suppose there is a scalar value, only single value, it's not in array or it is not in list. So rank is 0 and shape is empty. If it is a one-dimensional array or if it is vector, then it has rank 1 because dimension is only 1 and number of elements in that dimension is 3. So this is shape is 3. Now this is matrix. It is two-dimensional array, right? So as the dimensions are 2, rank is 2. Shape, in each dimension, how many elements are there? So in outer dimension, you can see that 2 elements are there. This is my outer dimension and these are 2 elements. So this is 2. In each of that element, there are 3 elements. So this is 3. So this is the shape of this 2-dimensional array. This is 3-dimensional array. So rank is 3. Shape is this is green color represents the outer dimension. There are 3 elements in outer and these 3 elements are enclosed by red bracket. So it is 3. In this red bracket, which is second dimension, there are 3 elements, 1, 2 and 3. So the number of elements in second dimension is 3. So this is 3. And the black represents the third dimension. In that, 1 element is there. So that is 1. So 3, 3, 1 is called it is a shape of this 3-dimensional array or 3-dimensional tensor. Understanding this, you must be able to decide the rank and shape of this Any one of you can let me know what is the rank and shape of this tensor? Rank and what is shape of this tensor? Rank is 2 and okay. Rank is 3. I have got two different answers. Let's see, rank is 3 because there are 3 brackets. That's why I have highlighted here 3 brackets. This is outermost dimension. Red color represents the outermost dimension. This blue color represents the second dimension and this green color represents the third dimension. So here you can see that in outermost dimension we have 2 elements which are enclosed. 2 elements are enclosed in blue bracket. In second dimension we have one element. That one element is enclosed in green bracket. And in that third dimension we have 3 elements. So what would be the rank and shape? This is rank, 3 dimensions are there, and in each dimension 2 blue elements, so 2 outermost, then 1, so 1, and in each of this inner dimension there are 3 elements, so this would be the shape, right? Now you will come to know that why I am discussing the shape and rank and why is it required? Because this is how data is fed to your neural network, to your machine learning model in TensorFlow, right? Suppose this is your model and you have data. See, generally we want to feed data, either text data or audio or video or images, right? We know that even if it is image, we convert that image into numerical form, and that numerical data is fed to neural network. For example, here you can see that the data is always represented using tensor, that is using array. It may be one-dimensional array, two-dimensional array, three-dimensional array, right? It depends on type of your data, right? So this is how this data is fed in the form of tensor. This is matrix, right? This is vector. So we can say that this is one-dimensional. This is one-dimensional tensor. This is two-dimensional tensor. Now, let me explain you that how we fit this data to machine learning model if it is image, right? I have taken the example of color image. You will understand, with this discussion, you will understand how we can fit black and white image. If it is color image, we know that it is represented with 3 channels, this red, green and blue, right? And each channel is represented by 2-dimensional array, because this channel is represented by intensity values. Intensity value in red channel, intensity values in, so if it is 100 cross 100 pixel image, let's assume that it is 100 cross 100 pixels image. So in that case, this size of this matrix would be 100 cross 100, right? Such how many matrices are there for color image? 3. Because 100 cross 100 matrix would be there for red channel, which will represent the intensity values of red channel. Second 100 cross 100 matrix would be there to represent the green intensity values for 100 cross 100 pixels. And similarly, we will have 3, right? So 3 matrices are there, and each of this matrix means 2-dimensional array. So what will be the shape and rank? What would be the rank and shape for this data if I want to feed one color image to machine learning model, which is built using TensorFlow? What would be the shape, right? The data size would be, yes, rank is 3. You are absolutely right, because rank would be 3, right? Rank kya hoga? 3, because we have 3 dimension. The first dimension represents the number of channels. Second dimension represents the number of rows, and third represents the number of columns. So outer dimension will have, the shape would be 300, 100, because our outer dimension has 3 elements, second dimension has 100 elements, and third dimension has 100 elements. I hope this is clear to you, right? Now you can multiply this. How many values we are inputting to input one image to neural network? 3 cross 100 cross 100. So this is 30,000, right? to feed one image to your neural network model or to your machine learning model, 30,000 values you have to fit to your model. 30,000 input values are there. So 30,000 input neurons will be there in your input neural network. You can imagine the complexity of neural network when the image is of high resolution. Today our smartphones, our smart cameras, they are generating images in megapixels and in megapixels, right? Or in kilobyte pixels. So you can imagine the number of pixels in one image, and then you can imagine the 3 channels, you multiply by 3, right? For example, even if it is 1 megabyte image, 1 megabyte means 10 raised to 6 cross 10 raised to 6 pixels. 10 raised to 6 cross 10 raised to 6, and if it is color image, 3 channels. So 10 raised to 6 cross 10 raised to 6 cross 3. So calculate the number of pixels which you have to input to your model to feed one image. Now we just talked about the training and training of the model. When we want to automate something, we first train our model. To train model, we have to feed as maximum as possible number of samples so that it will learn good and it will provide us accurate results. So if we are training, for example, if we are training our model to identify the shapes or to identify the colors from image, we may fit 1,000 such images. 1,000 is nothing for complex problems. We may fit 1,000 images. Now one image, 3 cross 10 raised to 6 cross 10 raised to 6, such 1,000 image you have to feed. So you can imagine the amount of computation involved when you train your model. You can imagine the amount of computation when you train your model, right? And I told you that all this Netflix, Flipkart, Facebook, etc., Amazon, they are using several, they are providing several services based on images using machine learning. So their models, they are trained with this number of a massive amount of images, and you can imagine the high amount of computation. And that's why TensorFlow is used, because it eases the computation. That I'll discuss again. Okay, this is how the tensor, this is how the video is represented to your model. Because suppose now we just talked about the image and the amount of computation involved when you want to train your machine learning model with images. Now suppose you want to train your model with videos, right? So video, how videos are processed, video is generally converted into number of frames, and each frame is nothing but one image. So suppose I want to process, suppose I want machine learning model to process one video, then that video will be, say, video will be converted into n frames. Now each frame is nothing but color image, and just we discussed about the shape and rank of the color image, right? So if it is video, then there are n frames. Each frame is color image. So there are three dimensions for each color. So entire video is represented with 4-dimensional array. Outermost dimension represent the number of frames because it is a set of images. So how many images? N images, n frames are there. So outermost dimension represents the number of frames you have created from video, that is n. Each frame consists of 3 channels. So second dimension has number 3. And then it depends on the resolution or number of pixels in image. So video is represented using 4-dimensional tensor or using 4-dimensional array, right? So this is how videos are represented to machine learning model. Okay, now before we move forward, I would like to tell you that why the software is called TensorFlow. As you have observed in those data flow diagram, the edges are tensors, data, and the nodes are operations called TensorFlow operations. You must have observed in those data flow diagrams that tensors, that is data, they flow throughout the graph, that is from input to output level, as inputs for various tensor operations, which in turn produce new tensors as output, and thus the name is tensors flow. That's why it is TensorFlow, because tensors flow from input to output layer, right? As they flow through this diagram, the name is TensorFlow. Okay, now the question is why TensorFlow has become so popular and why it is preferred by most of the researchers and most of the machine learning engineers, right? I too prefer TensorFlow for machine learning applications. TensorFlow, why it is so popular when there are so many alternatives available to TensorFlow. These are all libraries which can be used to implement machine learning models. Theano, Keras, Torch, Caffe, right? All these are libraries which can be used to build machine learning models, right? So many options are there. But then why the TensorFlow has become so popular these days? Due to this reason, it has become so popular. Its ability to perform partial subgraph computation in neural machine translation, it reduces errors by 55% to 85% compared to other tools. Its ability to iterate quickly to train models faster and run more experiments, and moreover it supports CPU, GPU and TPUs. So when you working with image data set, then TensorFlow is most suitable tool because it supports GPU. GPU is not supported. GPU is most of this tool so if you have worked with Colab during your first app, during your menu, you can choose GPU, TPU for your project, right? That whether you want to work with GPU or TPU, which is not you are working on the same with your machine. It's possible in Colab and you can experiment with this processors also, GPU. We have taken these logos from TensorFlow website only. You can visit TensorFlow website, you will find these logos there. These are the companies using TensorFlow for their machine learning based applications. They have built, these companies have implemented their machine learning based models using TensorFlow, right? So you can definitely, it is the product of Google. So Google has used it. Intel, DeepMind, this is Facebook application, right? eBay, Coca-Cola, right? All this popular, see, Uber, MI, Snapchat, they have built their machine learn, they have built their applications, even LinkedIn, using machine learning based application using TensorFlow, right? These are only some of the companies. Even you can find Twitter here, right? And these are the real-time examples using which have been implemented using TensorFlow. Just we have discussed, no, this we have not discussed. We discussed DeepMind. Deep speech was not discussed. Deep speech, this is the application Mozilla's open source speech to text engine. Deep speech is Mozilla's speech to text conversion engine. And this is implemented using TensorFlow. All these are machine learning, deep learning based applications, and they have been implemented using TensorFlow. This is Google Translate. Everyone knows, right, that Google provides a service to translate between 100 plus languages, right? And that service is implemented using for accurate translation. This is machine learning model that Google has developed, and this machine learning model has been implemented using TensorFlow. This is rank brain. Okay, let me tell you that all these applications also I have taken from my presentation, from my PPTs created in June 2019. So by this 1.5 years, more latest applications must have been developed using this TensorFlow, which I have not included, but these are also very popular applications, right? Rank brain, it is also developed by Google for search ranking on google.com. This is Stanford University's research project, Massive Multitask for Drug Discovery. All of you are aware that today we are using machine learning and deep learning for drug discovery to reduce the cost and to reduce the time for drug discovery, because traditional process of drug discovery takes around 10 to 12 years. But when you use machine learning, this time is reduced and even cost is reduced. So drug discovery using machine learning is very popular today. And this Stanford University project, for this project, they have developed deep neural network model using TensorFlow to identify promising drug candidates. This general application anywhere for image recognition, you can build machine learning model, and machine learning model can be developed using TensorFlow. So all these companies, they have developed their image recognition. I mean, they have developed their applications that involve image recognition using TensorFlow. This is Airbnb, eBay, Dropbox, Snapchat, Twitter, Uber, SEP, right? All they have Google, Facebook, Instagram, even Amazon. They have developed their image recognition based applications using TensorFlow. Deep Dream that we discussed, that is captioning software, automated captioning software by Facebook. Allo, I have not used it recently because I used to discuss this application, but somebody told me that this is now not available. I'm not sure whether it is there or not, but Allo is Google's app, and it is like virtual assistant only, Google Assistant only. So earlier it was supporting only, it supports text chat. It supports text chat, and to suggest responses similar to the smart reply feature seen in Google's inbox by Gmail, Allo has used machine learning, and that machine learning model of Allo app, it is also developed using TensorFlow. This is also Google's service, right? These are other applications. GE Healthcare, very active and popular organization to do research in healthcare. They have used machine learning models to identify anatomy on MRIs of the brain, and this machine learning model to identify anatomies on MRIs, they have used TensorFlow. Even PayPal has built machine learning model for fraud detection using TensorFlow, right? So these are the other applications. So you can see that why people prefer TensorFlow. You will find more than 4,000, 2,000, 4,000 applications using TensorFlow within this short span of 5 years, because it was launched in 2015 and this is 2020, almost 5 years, because it was launched in November 2015. So you can see that it has become so popular. You will find several projects using TensorFlow on GitHub, on Kaggle, etc. And this is the case study I have included here, that I told you that I prefer TensorFlow because it is a Python open source library, very powerful, right? On top of TensorFlow, Keras is built. So Keras is more powerful than TensorFlow because it supports low-level API and TensorFlow supports high-level API. It is in TensorFlow you have to write more code compared to Keras. In Keras you have to write less code. And Keras is built on top of this TensorFlow. So if you want to learn Keras, you have to first learn TensorFlow. And here I have included one case study this is done by my research scholar, early detection of hypothyroidism in infants using deep learning. This model, this solution we have implemented using TensorFlow. In this research, we have tried to identify whether infant is suffering from hypothyroidism or not from facial features of infant. So we have considered these 5 facial features in this problem to identify whether infant is suffering from hypothyroidism or not, and because the complications of this disease are very severe in infants, and it is very difficult to identify whether infant is suffering from hypothyroidism or not during the initial stage of this disease. So we have created a model. This is deep learning based solution. We collected these images consulting several pediatric endocrinologists, because this is rare disease and you'll not find pediatric endocrinologist in every town or every city. So we consulted a pediatric endocrinologist of Mumbai, Surat and this Ahmedabad, and we got very less number of images. But still, this was the first attempt to identify this disease from facial features of the infant. So you can see that this process will look similar to the process we discussed for data science and process we discussed for machine learning, right? These are input images. This is a set of images. The face detect. Then first from images we are detecting face because we are considering facial features to identify whether infant is suffering from a disease of hypothyroidism or not. And here you can see that we are extracting features. This is the training phase and this is testing phase. We are extracting features using convolutional neural network CNN, which is based algorithm to extract the features when you want to automate feature extraction. Okay, so this is CNN is used, and here you can see that the last layer of this, the last fully connected layer, is replaced by R classes. This is binary classification problem. We want to know that whether infant is suffering from hypothyroidism or not. So if infant is suffering from hypothyroidism, the class would be this 1, and this is 0 that represents infant is not suffering from hypothyroidism, that is infant is healthy. So this is binary classification problem which we have solved using the CNN, and we have implemented it using TensorFlow. I'll present that screen and I'll show you the code in Colab. And we received 84% accuracy. These are the testing results. Here you can see that this is the performance analysis considering normal facial images. So this is the predicted class and this is the class provided by doctor, right? So these are the misclassified samples, where you can see that out of this in this category. In this category also, these two are misclassified and these are correctly classified samples. This is the performance analysis considering slant view and slant facial images. This is lower brightness, or one is misclassified, and in this you can see, okay, now I would like to show that how we have implemented this using TensorFlow. Okay. Oh, this is, sorry, I have said meeting window. No, share web browser. Can you see my browser?
No, madam.
Oh, you can't. Now can you see my browser?
So now notebook has come.
Yeah, notebook is there, right?
Yes.
So here you can see that just a second. Yeah, here you can see that this is Google Colab. As I have told you, from here you can change runtime. You can select from here whether you want to work with GPU or TPU in TensorFlow, right? So this facility you will never get, otherwise you have to purchase very costly GPU when you want to work with a huge set of images or huge set of videos, because our normal machines, they cannot be used to process such a huge amount of data, right? So when you are working in Colab, from there you can use whether you want to work with GPU or TPU. Here you can see that I have just mounted the drive here, and this is how you can install TensorFlow in this Colab. So this is installation part, and then this is the training model which is created. So all the required libraries have been imported here: the Matplotlib, Pandas, Pickle, NumPy, all. And you can see that the Keras have also been used too, because we are working with deep learning model. So Keras is most suitable for deep learning models. So you can see that all necessary classes and libraries have been imported here. And After that, all the hyperparameters are set. We have used ResNet 50 architecture for this. So you can see that all the hyperparameters are set here for ResNet 50 architecture. And this is the training model, which is then after setting the hyperparameters, the training model is executed for some number of epochs, right? So you can see that after this, I cannot execute this right now because otherwise it will take more time. Yes, I can change the number of epochs, but then the training will take some time. We will not get immediate output. So that's why I'm showing like this. So this is the training. You can see that. Okay. After that, after training the model, we are computing here, we are plotting the accuracy and loss, right? So this is to plot the
Madam.
score. Yes.
Madam.
Ma'am, we are unable to see the code. We are only seeing the line pip install TensorFlow. Afterwards, we are unable to see anything, ma'am.
Okay, okay. I'm scrolling, but you are not able to see.
Yeah,
Yes.
yes.
You are sharing a web browser. Yeah, I'm sharing the web browser, but
Slow because this is a program from Google Colab. So it takes
okay.
time, and
So
if internet is slow,
huh.
then we can't able to get simultaneously.
Okay, can somebody guide me that how can I share my full screen using this WebEx, because I'm not much familiar with WebEx. So if this is share, then there are only three options: share content, share web browser, and share by meeting window. But I want to share the computer.
Ma'am, just stop sharing, and after that you'll get downwards. Share screen one. Then you can share the entire screen.
Okay, let me
Stop sharing.
stop sharing. Stop sharing. Okay.
Yeah. Then then you'll get there. Share.
But then too, I am getting only three. I tried
No.
this today morning only, but then too, I am getting three options.
Upwards, it will show screen one, something like that.
There are 5 options, but 3 are enabled and 2 are disabled options. And that share remote computer, sharing my computer is disabled. Only 3 options are enabled: share content, share web browser, and share meeting window. There are other 2 options also, but they are disabled. I'm not able to click on that. But let me now again try to share the web browser.
I'm having two browsers.
Vaishali ma'am, I tried to share a browser only, but then you are not able to see the code. But let me try once again. Let me know if you can see my screen or this Colab browser. Can you see my browser?
No, ma'am.
No. Okay. I wanted to show you that how easy it is to implement such machine learning and deep learning models using TensorFlow, and that's why we prefer, and most of the other researchers, they use TensorFlow. Anyways, I have shared it. You are sharing the web. See, I am getting this message also that you are sharing a web browser. And I'm getting message that people are viewing your web browser, but you're not able to see my web browser, right? Okay, if you can't see, then okay, I don't know how to share it now. So fine, that's all from my side. Or I may show you the same in my next session during the third FDP, which is specifically on healthcare and use cases of healthcare. Okay, fine. So, 'that's all from my side. Thank you everyone for listening patiently. Yeah, I tried multiple times, but I'm not able to share that web browser. So I'm sorry. Next time I'll try well in advance and then I'll present it.
It's okay, madam. No problem. Okay. So thank you very much, madam. Thank you very much. And I like the way you have presented your entire TensorFlow concept. Very interesting. Few examples were very interesting, very encouraging examples. And your presentation was also very good. Slides were very good, very nicely prepared slides. So thank you very much. Thank you for accepting this invitation and sparing Madam your 2 days. You can see participants are commenting that we had an excellent sessions. So thank you very much, and looking forward for in FDP3 also one day one morning session you will be taking on the case studies related to healthcare sector. So looking forward for that session as well. Thank you.
Thank you very much. Thank you
Yeah.
very much, Surendra sir, for providing opportunity and to interact with such an active set of participants. Thank you, participants. Thank you, everyone.
Kindly accept this is our virtual memento, we'll call it.
Yeah. Thank you very much, sir. Thank you. Thank you.
Okay. So thanks a lot, ma'am. We'll meet again.
Yeah. Thank you.
So thank you, participants. We'll be meeting in the evening at as usual at 5 o'clock. Okay. So thank you very much.